this is problem 125 of Neetcode on 50 gas station. So we're going to be given an amount of gas station and they're going to be basically connected. So the first index is connected to the last index. They're making up a circle. And we are going to have two array of integers, gas and cost. And at every position, we have the amount of gas we can get from a particular station and the cost it will take us to get this gas. We want to know if we can store an unlimited amount of gas, if we are allowed to create or to go all the way around the circle once. If it is not possible, we're going to return -1. So for example, here at the first station, we can basically fill our car with 1 unit of gas, but it will cost us 2 units of money. So with only this, we will be in the negative. So the only solution is to take this 4. So we're going to take 4 units of gas on the last index, and we're going to pay 1 unit of dollar for this. So now on the next station, which is going to be the 1, I will start with 3 units of gas and I will add 1. So I will be at 4 units of gas and I will pay 2 units of money. And when I say money, could actually just be the cost of gas it takes to go to the next gas station. So I basically, to go to this first index, it will cost me 2 units of gas. So starting from this one where I had 3, I will have basically 1 unit plus this 1, so I will be at 2. And now when I go to the next index, it will cost me 2, so I will spend 2. But I will also add 2, so I will be at 0. And then I will go to the last index. And whenever you reach the last index, the game is over. So let's see how we can solve this using a greedy approach. Let's say that the purple numbers here are gas and the green ones are the costs. I've drawn the delta, which is the difference between the gas and the costs, and it basically tells us whether we are in the negative or in the positive inside each station. And now there's one thing I want you to notice is that by having our delta array with this, it makes it pretty obvious that the starting index is here. Because I think I didn't specify it, but in this problem, we have to return the index of the station. We have to start at if we want to complete the entire circle. And I think that drawing the delta array makes it quite obvious that we're going to have to start from this tree. And there's another thing too that we have to consider is that if the sum of the costs is greater than the sum of the gas, there's absolutely no way for us to actually go all the way around the circle. That just won't be possible. Like for example, if I go back to this example and I add all the gas, right? I'm gonna have 10. And if I add all the costs, I have 9. So the simple fact that along our way we have more gas than costs means that there will be a solution. And if I take this counterexample and I add all the gases, I have 6. But if I add the costs, I have 7. Meaning that it doesn't matter where I start at. If the sum of the costs is greater than the sum of the gases, we won't have any solution. We're going to return -1. So let's do this right now. So if the sum of the cost is greater than the sum of the gas, we're going to return -1. All right. And now let's see what is the potential of this delta array that we just drawn here. Okay, let's say we start from there and we take a look at this delta. We want to ask, is this delta positive, negative? If it is negative, we just want to scratch them and go to the next index. Because when we add the sum of the gases, we had 15. And when we add the sum of the costs, um, we also had 15. Meaning that we'll end up having 0 unit of gas, but we'll end up the at the um, at the end of this circle. So since these two are equals, we know that there will be one solution. There is one way to go until the end. So now we are here. We just reset our difference, and our difference now is so it's going to be 0, but the difference is going to be -2 when we take a look at the difference between the gas and the cost. So since this is negative, we know we can't start from there because we won't have enough gas to even reach the next station. So we're going to go see our next indexes. And once again, the difference is negative. So we are not going to be able to start from this position. And now we have 5 and 2, which is our first positive difference. So we will actually make our starting index to be this index. So it's going to be called a 3. And I will keep my difference here to be 3. Because it is possible that along the way, we have a positive solution. Like, for example, here. What if we had 1 instead of -2? Well, technically, at this very position, we will set the starting index to be this one. But right after, we're going to have a -2. And this -2 is unfortunately going to set this equal to a -1. Meaning that even if we start from this 1, going to the next station will make us in a situation, it will place us in a situation where we can no longer move forward. So this is the reason that whenever we have a negative difference, well, that's our clue that it will not be possible to go all the way around the circle. So we're going to set the difference to 0 and go to the next index. But if the difference is positive, we want to carry that difference to the next numbers to see if it still works. Because if you find a path that can allow you to go all the way around the circle, it must mean that you never go into the negative. You can go into 0, but you can never go into negative, because otherwise you will basically lack gases to even complete the circle. So with that being said, let's just move to the next index. See its difference. Its difference is 3. So now we know we have basically 6 amount of gas. And this is going to be enough for us to complete a circle. And in the meantime, we kept this index to be at position 3. So what I'm doing is that I'm going to create a difference, 0. And I will create a starting index of 0. And I'll go for every single number. So I'll say for I in the range of gas, I want to say that the difference is plus equal the gas at this index that we can get minus the costs we'll need to pay to go there. If this difference is negative, then we want to set it back to 0. And we want our starting index to be the next value, so I plus 1. And then we can return the starting index. Awesome. So notice that we are not storing any additional memory. So this is giving us a space complexity of big of 1. And also in terms of time complexity, we are going once through every single numbers. So this is going to give us a linear time complexity, big of n. With that being said, I hope you enjoyed the video and I hope to see you in the next one.